Why do I feel like I'm at a monster truck rally? All right, if you could take your seats, our next speaker is about to get going here. The next talk is called Evolution of Container Security. What's next? And if you could please put your hands together for Fernando Montenegro.
Thank you very much, everybody. It's a true honor to be here, and especially thank you to everyone who's new coming to BSides. This is a wonderful event. I hope you have a great time here, and I hope to see you speaking next year here. I had a few objectives for this talk. I want to talk a little bit about where container security is nowadays. I want to present it in a broader context. I want to touch on a few key market trends, and I want to discuss what's next. Just as a point of introduction, I've been a member of the security community in Toronto for about 18 years. I'm now an industry analyst at 451 Research. I've been in sales engineering roles before and whatnot. And I have a small disclaimer. First, these are what I'm presenting are my opinions as an analyst as I cover this space, which basically means I reserve the right to be woefully wrong about what I'm talking about. I will mention tons of vendor names. That's not an endorsement of those vendors. And to the best that I can do, I try to make lists as comprehensive as possible, but in most cases, especially container security, I end up missing quite a few. So the list is more representative and not comprehensive. So I mentioned I'm an industry analyst, and I wanted to talk about the methodology that I use to build this presentation. 451 Research has a long history as a research firm. There are two major sources for this. One is we run what's called the Voice of the Enterprise survey, which is a long-term, relatively, serious study on survey data. It's not your typical $5 for an answer kind of thing. We do have strong methodologies about it, and we run them on a yearly basis. Different quarters, there are a different set of questions. The other thing I've used for this research is just my time as an analyst talking to customers who have inquiries with us, looking up, doing independent research on vendors and so on. So what did that research show? Why am I here talking about containers? Because of this. So this is the data from, this is a 2018 survey data that just came out. And if you ask, when we asked people what's the features they're using the most, containers came out as one of the highest usage features in public cloud deployments, right? This is particularly interesting because containers are something that to some extent they've been used in different ways by different people. We also asked them, what is it that they are planning to do in terms of features as they roll up, as they improve their presence in public clouds. And as you can see there, containers takes a very strong second spot right after machine learning, right? And to some extent, the machine learning component is something that a lot of the larger providers are offering as a service, right? They're specifically offering it as a service as opposed to having customers spin up their own TensorFlow or Keras pipelines. So you can say that containers are the highest, the most interesting footprint that people are going to be deploying in public clouds. Now, why is that? And the best that we can come up with is based on this question, like as people approach cloud-native applications, as your company is building an application in the cloud, what it is that you're looking to do. And the top answer is you want to design it to run effectively on any cloud environment. And it's this portability around containers that makes it so attractive for this use case. It's the notion that, and we can debate this, I'd love to have the conversation around whether we're doing, how we spin up workloads in multiple clouds, but the fact of the matter is containers are an incredibly portable format for doing things. Now, one thing I don't want us to ever forget is that containers came about for a different reason. Containers came about to resolve this problem, right? This is why, I'm an infrastructure guy. I love networking and infrastructure, but containers came to mind because we wanted to, hey, it doesn't run on prod, but it runs fine on my environment. So it is fundamentally, the container image for containers, the definition are, it's an image format where you can pack dependencies, and it's a runtime that's going to execute that. So we've kind of gone away from this theoretically to something like this, right? A rainbow of containers. Containers are going to solve everything in technology, and it's not quite like that. There's a lot to containers that we still have to work through. I came across this cartoon a while back that I think is something I think about all the time, right? The reality for most organizations is that migrating a legacy application to a cloud environment is much more like this than, hey, I'm going to just spin something up and off we go, right? And what this means is that discussions around container security are much more interesting in terms of understanding where the container security technology fits within a much broader life cycle of things. So what I wanted to present was how I frame my research in terms of container security in terms of a container lifecycle. Before we get to that, though, just a quick recap. Container technology has been discussed significantly over the past little while, but I wanted to do a refresh and mention that fundamentally what we're talking about with containers is there is an image format where people package their dependencies. Those dependencies, then that image format then gets put into an environment where there is some sort of runtime that unpacks that environment and executes that code, right? And there's a difference between Linux environments and Windows environments in what the subsystems are. In Linux, we've all, or many of us have talked about things like namespaces and C groups and capabilities and so on, which is basically the way that Linux will, and I have more of a Unix Linux background, so that's where I'll focus on. But it's fundamentally how the runtime is going to be able to segregate the information between the processes that are running on one container versus the processes that are running on another, right? And Microsoft has had container support in Windows since 2016. I believe Windows 2019 is just about to be released, and that has built-in container support as well. I did not include 2019 slides here. So, understanding, when we talk about container security, a lot of times a lot of the material I see, we spend talking about, okay, so how do C groups work? How does SE Linux work, AppArmor and those things? But there's a much bigger story around containers. So, at the risk of simplifying it a little bit too much, I wanted to talk about what do I see as a pipeline for a container image, right? You start with I'm going to call it an artifact, right? I mean, something that, let's say you download an image from somewhere. Let's say it's Docker Hub. Let's say it's another sort of repository that you had access to, or you create one, but let's say it's a download. Theoretically, what should happen in most places is you download that into your CI/CD pipeline. So you're building code, you're bringing the dependencies into your pipeline. That pipeline is building the new version of your application, of your container. Then that gets pushed to a container registry where it's going to be instantiated later on. And of course, I'm glossing over a ton of material in terms of dev, test, and prod. There's a lot of things going on here. Unfortunately, sometimes this happens as well. People just download images off the internet and just put them on their registries, and they should really not do that. Once they have that container registry, then when you're going to execute that, you're going to have a runtime environment. So that's basically where your Docker runtime is running, or other runtimes. We'll talk about that later. That is going to be made up of the environment where that container is running. So how that host is processing containers, as well as the workload that is running itself. So when I am thinking about what is a specific container doing? And then that's where you pull the image from, and that's your container runtime. So I call this the build phase, the ship phase, and the run phase. Now, one of the things that we should keep in mind, and as a tee up to the next presenter, you cannot, or realistically, most large or most production container deployments have an orchestrator layer on top, and that I will put in that I typically put in the ship phase as well. So I want to talk a little bit about build time considerations for containers, and I'll just skim through this a little. But during the build time, what you should be thinking about as security professionals is fundamentally application security. What about the code that is actually going into that container? You should be thinking about how you scan the images, as you're building the image, when that is when you're creating that image that you're going to push out later on. How are you doing vulnerability management on those components? You don't want to import an old library that doesn't that's got a ton of vulnerabilities. By the same token, you don't want to import libraries that may break your policies. Maybe you have a license restriction. You cannot run a GPL code, for example, right? So you have to have a layer of checking for that there. And the issue, what I like to say is, realistically, issues should be treated as defects on the pipeline so that your development team can just process them going along. After that, you sign your image. One tip I like to comment on is the notion that ideally, it's at the build time for your container that you're going to reduce the size of that image. And one of the ways to do that is something called multi-stage builds. I have a copy of a file here. Basically, you start with an initial image from the first image builds the minimum libraries, and then you build your application, and then you copy that into a very small container. Some of the examples, I don't have them here, but they talk about how you can reduce, while an image might be 300 megabytes in one traditional way, you can bring it down to 5 or 10 megabytes sometimes. That is the build time considerations. When you're talking about ship time considerations, there are two things that people should be considering. One of them is on the image registries themselves. And the topic here is, again, you should do vulnerability management on images that are on your registries, because you may build something today, you may push it to your registry today, and you may not use it for 2 weeks. And lo and behold, somewhere in those 2 weeks, a new vulnerability pops up on that image. Right? RBAC stands for Role-Based Access Control. I'm using that as a catch-all phrase to refer to what permissions you are giving people in the organization to ship images back and forth. And the other ship time consideration is how you secure your orchestrator. There's a wonderful session coming up in a little bit about Kubernetes security, so I'll leave that to Hayden. But there are different considerations, and I'll share the slides later. During runtime, as I mentioned, there are two elements. One of them is how you do host protection, how you secure the workload, how you secure where that your container workload is going to run. And then there is the container runtime itself. The host protection is your traditional, how do I secure a server? You use CIS benchmarks to harden it. You use firewalls and network access control to block the host. For the container runtime, your major consideration then becomes what exact actions is that container taking? Right, so you can analyze system calls. You can segment the network with network level segmentation as well. I mentioned here briefly alternate runtimes. One of the developments that have happened over the past few months is that couple of years is that there are a number of different runtimes for Docker for containers that each have different pros and cons in terms of security features. Right? Some of them segregate based on VMs. Some segregate just based on system capabilities. Taking a quick look at some of the trends that we're seeing in industry. Right? I think that one important trend as you look into container security is that there has been significant governance efforts around container security. Right? NIST released an application container security guideline in September of last year that's quite informative. The Center for Internet Security has, as it says here, Docker and Kubernetes benchmarks. And I put the asterisk here because I think there's a CIS benchmark for pretty much anything, including all the large cloud provider environments where you're going to run things. The Open Container Initiative is the effort that defined the image specification and the runtime specification for containers. So as organizations create new container runtimes, they're usually building them to OCI specs. And the Cloud Native Computing Foundation is the one that's mostly responsible for it's a very large effort, responsible for Kubernetes, and specifically the container networking definitions. It's coming out of the CNCF. And both OCI and CNCF are under the auspices of the Linux Foundation. Right? A couple of points on NIST, the NIST guidance. It's a very easy read, but the key points are, and I find this interesting, one of their key points is fix the organizational aspects. So here we are on a container security technical document, and they are telling us to pay attention to the organizational aspects of how these things get built. Right? There's a little bit more guidance around container-specific, try to use a container-specific host versus a generic host because the footprint is going to be smaller, the attack surface is going to be smaller, and a couple of other things. But also, where possible, think about updating whatever vulnerability scanning or runtime scanning tooling you have for containers versus using a standard default. I mentioned the CNCF. I'm not expecting you to be able to read this. These are all the projects that the CNCF is responsible for. This, again, you'll get the slides. This is a great overview of pretty much anything to do with cloud-native technology. Right? Another trend I'm seeing significantly is what I call the rise of the managed runtime. So this one stands for Azure Container Instances. This is AWS Fargate. This is Google Kubernetes Engine, and I just picked the 3 top ones. The other cloud providers have them as well. But this is the notion of you as a developer, you don't need to worry about the host runtime anymore. Really, what you should do is you give them your container definitions, right? And they will orchestrate it for you. You don't have to worry about if there's a vulnerability on the back end or not, on the host environment. And this is a significant thing from a security perspective because now you no longer have a host to work from. Right? So what ends up happening is that you have to start instantiating security within the container itself versus having to rely on a system-based agent. Another trend I like to talk about is that there are different commercial approaches to container security. Right? There's 2 slides. The first one, I compare. These are all the cloud-native, container-specific vendors. Twistlock and Aqua are 2 of the most usually recognizable ones. And they come with the benefit of having very specific, very rich container security features with the downside of, hey, it's another vendor that you have to manage. Right? On the flip side, the names you have here, Black Duck, Synopsys, Trend, Cloud Passage, Qualys, Rapid7. These are some more established vendors in most enterprise environments, and those vendors have rapidly adapted their tooling to support containers as well. When I say adapted, I mean that they've added container functionality. Tenable, for example, bought the company FlawCheck a little while back. But what they are doing here is that they are doing this by adding the functionality not to a level where these more specific vendors are. So depending on the tooling depending on your needs, you may do just as well with your container security, with your existing enterprise security vendor for some of the container security features. Right? The other thing I wanted to mention is that, especially in enterprise environments, it is unlikely that you are going to be deploying containers in production by pulling images and instantiating things yourself. What's more likely to happen is that you're going to leverage a container platform. Red Hat has OpenShift. Docker has an Enterprise Edition version. Pivotal has the Pivotal Cloud Foundry. And I mean, Mesosphere has DCOS. Rancher has Rancher Labs. And what these tools have is that they have a broad set of services, of security functionality, again, at the downside of potentially having limited support for new features. And what they will do here is that they will then, typically these companies will partner with the newer ones for some of that more advanced functionality. I also have here the cloud providers themselves, because they are adding container security functionality themselves, right? And one of the things, for example, that was just announced at Google Next, Google now has support for what they call binary authorization, which is they themselves are going to lock you from running unauthorized images on their Kubernetes environment. So now you can start leveraging what the provider themselves is doing. The downside, of course, is limited portability. So we talk a little bit about trends. Where do I see container security moving forward, right? One of the more interesting developments that I think are coming is the notion of a service mesh, right? And the service mesh is a higher level construct on top of an existing environment that is responsible for things such as how do you route traffic between multiple containers that are running? How do you do, that's a tough problem on Kubernetes and containers, which is how do you observe traffic? Like how do you do debugging and so on? And service meshes have a security element as well. They will, bless you, they will have a, they have traffic encryption usually built in for mutual authentication via TLS, and they will have some level of auditing and fine-grained policy. This container or this pod can talk to this pod elsewhere. And this here is just an example of the Istio framework. We can go into more details later if need be. Where does this fit into the broader theme of that vision of this framework that I use? I see service mesh fitting here. It's a way to control that runtime where you're going to run. So you're going to be able to, it doesn't matter where you're running, you can have a service mesh that's going to distribute it across, right? The other thing that I think is important from a container security perspective to be aware of is not the container itself. It's the notion of event-driven functions as a service, which people sometimes shorten to. There's a discussion on whether that is serverless or not, right? I'll consider, I like to be a little more precise. And if you're not familiar with this concept already, it's the notion that you are going to be not writing anything else other than the business logic for your application, but you are going to take the services, you're going to tie together services from the environment where you're running to do whatever it is you want to do. It's a fantastic example. Lambda is one of the more popular ones, but both Azure and Google have them as well. And there's other efforts, OpenWhisk, I believe, is IBM's, and there's other efforts for doing serverless. But fundamentally, they all revolve around the same thing. You're writing code. You're no longer managing infrastructure, right? Again, there is no host to monitor it from. And security then becomes an application security, and dare I say, an anti-fraud conversation more than an infrastructure one. So I just want to recap. We were going to talk about containers in context. We did. I talked a little bit about our adoption. I talked a little bit about this notion of build, ship, and run. We were going to touch on some market trends. I did add something around governance, competition, and new services that are coming along. And we were going to talk about what's next, right? So I think service mesh is very interesting. I'm talk a little bit about recommendations now. So what do I want you to leave this presentation with? Number one is that don't talk about container security in the context of the runtime alone. Don't talk about container security in the context of container escapes from a host environment. There is a much broader context on which container security falls, right? One suggestion is that as people move to runtimes that are more independent, like those managed runtimes, don't pay so much attention to that host environment. Pay more attention up front. I think that what you're going to find out as you look into container security is that a lot of the benefit you're going to get will be from working with your developers to build that security into their pipeline. And if they're not using CI/CD, if they're just downloading images off the internet, at least doing some level of sanitization on the images that they are pulling from. If I had to suggest how you would split your time, I would suggest something along these lines. 50 to 60% of your time should be on the build phase. 20 to 30 on ship, and 10 to 20 on run. But again, reserving the right to be wrong. I'll leave you with some very interesting projects that are usually open source around these areas: vulnerability scanning, hardening, monitoring, and a couple of others. And these are the sources of information that I go to on a regular basis for anything to do with container security. Right? There's more, of course, but this is a really good start. I'll leave you with one idea that's not mine. Kelly Shortridge, she's a security professional. Has a great grasp on DevOps and security. And she argues, this was just recently, DevOps is actually InfoSec's best friend, right? And she's right, right? I think that we're trying to do a lot of the same things. We're trying to get code to run the way we want it to run, and no more than that. We're trying to minimize the impact on the environment, and this is a great way of doing that. There's my Twitter handle. If people want to discuss publicly, I'll be around later for questions as well. But for now, thank you very, very, very much for your time, and thank you. Thank you very much.
Hayden to the stage. Hayden, please come to the stage.